let's work this problem. A car has a mass of 1,000 kilograms and is moving 200 meters per second, or 220 meters per second. 200 meters per second. That's be quite a car. How much kinetic energy does it have, and how much force is required to stop the car in 50 minutes? So I like to use the given, find, and solve format. So here's the road. Here's the car. It's a Tesla Model S. All right, and then so it has a mass, and I just picked 1,000 kilos. That's about 2,000 pounds. That's actually a really fairly modest-sized car. And then, and it's got a velocity of 20 meters per second. And we're going to slow it down. We're going to stop it. We're going to apply a force to the car, the brakes, and we want to know how much force does it take to stop it. And we'll say delta x equals 50 meters from here over to here. Now, when I solve problems like this, and when you're doing, hopefully when you're doing calculations like this, it's really helpful to use the given, find, solve format. This is how I did all my homework as an engineering major at Cal Poly. They require you to do this, and they still do, as last I heard. Even with nowadays, a lot of the homework is online. Though you do the problem and you plug the number in, and they tell you if you got it right or not. But still, this is a very good way of figuring out. So kinetic energy, KE, I'll use for that, and then part B, we want to know what force it takes to stop it. And then, so let's solve. So the car has energy contained in it because it has mass and it's moving. And the equation that it tells you how much energy that is 1/2 mv squared. Right, I gave you that formula. And the mass is 1,000 kilograms. And the velocity is 20 meters per second squared. And I try to do this so you really don't need a calculator. It's, well, 20 times 20 is 400. Well, 400, and 400 divided by 2 is 200. 200 with 1, 2, 3 more zeros. Now, a kilogram meter squared per second squared. Remember we said that a joule is a Newton times a meter. But a Newton, remember a Newton is a force. Force equals mass times acceleration. Mass, kilograms, times acceleration, meters per second squared is a Newton. And then a Newton times a meter is a meter squared per kilogram squared, right? Here's the Newton. And then a Newton times a meter gives you kilogram meter squared per second squared. Well, look what I got here. Kilogram, and then you square this, meter squared per second squared. So you really do end up with a joule. 200,000 joules. Looking at units is a great way of analyzing a problem, deciding if you're on the right track. Get used to that. I know most of you have at least had chemistry, right, or are in chemistry, and you've probably done a lot of that unit analysis kind of stuff. That's so important. Learning how to use units to solve problems, super important. Okay, so there's my answer for part A. Now part B. Well, we said that work equals force times distance. Now, the force that we're going to have to apply to this car to make it stop, we want to take all of its energy away. Well, how much energy are we going to have to take away? 200,000 joules. And is that right, by the way? Are you guys checking my arithmetic as I go? What? Okay. Well, so the work, I have to do work to take that energy away. Now, it's going to be negative work, and I'll tell you why it's negative work here in a minute. But to solve for the force, you just divide the energy you need to take away by the distance, or the displacement. And so the force is going to be equal to 200,000 joules divided by delta x, and delta x was given to be 50 meters. And what is that? 4,000 newtons. Is that right? Yeah. Agree with my arithmetic? Okay. And so that's my answer. Now, to take it away, do you see that the force needs to be to the left? Right? If the car is moving to the right in this picture, the force has to be to the left to take that energy away. When the force, notice that the displacement, that is the change in position of the car is moving to the right even as the force on the car is to the left. When the force is in that direction, but the displacement is in the opposite direction, when the direction of the force and displacements are opposite, that means we're taking energy out of the system. We're doing negative work, braking. Okay? Now, in a standard car, we just lost 200,000 joules of kinetic energy. Where did that energy go? Yes?
Friction, heat, air resistance, different forms.
Yeah, well, it specifically in a disc brake, your brake, it clamps and it rubs against, you have a brake pad rubbing against the brake disc, and it heats up the brake disc, and then that heat radiates out into the environment. So we just basically heated up the environment. Now, if you drive a hybrid car or an electric car, they use electromagnetic induction to brake, to generate electricity, and so that a big fraction of the energy gets stored in your battery that you can use later. And this is why hybrid cars that are still gasoline cars, like a Prius is still a gasoline car. It's just a very, very efficient gasoline car, because when it brakes, it's the energy, the kinetic energy you lose during braking, a big chunk of it gets stored up in a battery so that you can use it later. Whereas in a standard car, it just radiates out in the environment and it's lost. I mean, it still exists in the universe. Energy can't be created or destroyed. It's just no longer available to us. Okay. So anyway, any questions? Okay. That is all.